This chart compares the metabolic equivalents, or MET values, of common exercises. On the right, steady-state running demands a MET value of 7 or higher. On the left, Pilates hovers between just 3 and 4.5. Based strictly on acute caloric expenditure, the practice appears ill-suited for weight loss. Yet, rigid clinical data demonstrates significant, measurable drops in both body mass index and body fat percentage for regular practitioners. This forest plot from a Frontiers meta-analysis aggregates data from 11 trials tracking 393 subjects. Isolating the obesity data reveals a clear shift favoring the intervention, where subjects experienced a 4.2% reduction in body fat. This change occurs not through high-intensity exertion, but through a dual mechanism of autonomic metabolic regulation and structural neuromuscular repackaging. Tracking the sweat on a mat or the active calories on a smartwatch captures only a fraction of the physiological process. Acute caloric output is an incomplete metric for evaluating how human tissue is actually remodeled. This data point from the same meta-analysis isolates lean body mass. Notice the aggregate diamond marker sitting exactly on the zero line. Total muscle mass across the body did not universally increase. If total muscle volume isn't growing globally, the visible anatomical tightening must result from where muscle is built and how it functions. This diagram illustrates the structural layers of the abdomen. Watch as the superficial rectus abdominis fades out. The mechanical work of Pilates happens underneath, targeting the transverse abdominis, the internal obliques, and the multifidus along the spine. Clinical sonography proves that core stability training on a reformer prompts precise hypertrophy in these hidden areas. The transverse abdominis alone increases in thickness by 0.14 centimeters during active contraction. The internal obliques show an even sharper tissue response, expanding by 0.20 centimeters. The growth is localized to the specific fibers responsible for spinal and pelvic stability. By thickening specific stabilizers, the body builds a dense internal muscular corset. This fortified structure actively and continuously draws the waistline inward toward the spine. This localized growth pulls the skeletal frame into a tighter resting posture. The result is the visual marker of a leaner physique, achieved independent of the total mass shown on a scale. This corset is just one architectural component. The muscles themselves are wrapped and suspended by an intricate web of connective tissue called the fascial system. Traditional fitness routines, like running, cycling, or basic weightlifting, operate almost exclusively within the linear sagittal plane, moving straight forward and backward. Pilates breaks this pattern, forcing the body through the transverse and frontal planes simultaneously, applies functional tension across the entire fascial web. Combining these multiplanar movements with the scalable tension of a reformer's springs physically stretches and hydrates this connective tissue, reorganizing its structural integrity. As the fascia adapts to these complex directional forces, the biomechanical resting tension of the entire body shifts. The limbs and torso are held more tautly in space, creating a longer, structurally distinct silhouette. While structural remodeling dictates the shape of the physique, actual fat oxidation relies on a specific sequence of metabolic and endocrine events. The first variable is excess post-exercise oxygen consumption, or EPOC, triggered by the intense resistance of the reformer springs. This graph tracks oxygen consumption over time. After the initial moderate peak of the workout, we see a sustained elevated plateau. Tissue repair of the deep stabilizers adds roughly 5 to 15% to the total caloric cost of the session over subsequent hours. This afterburn contributes to a daily caloric deficit, but it is not the primary driver of the physiological shift observed in the clinical data. The critical switch lies within the autonomic nervous system. Chronic elevation of the stress hormone cortisol commands the body to retain and store visceral fat. Clinical studies confirm that practicing mat Pilates significantly decreases the mean stress index while actively increasing parasympathetic nervous system activity. Deliberate breath control and mindful movement physically downregulate the nervous system. Mitigating cortisol creates an endocrine environment that inhibits fat storage and permits long-term fat oxidation. The physiological data provides a clear picture. Pilates operates as an architectural remodeling system, not a cardiovascular calorie incinerator. If a significant drop in scale weight is the primary clinical objective, a sustained caloric deficit through dietary intervention remains an absolute physiological requirement. Examining the historic roots of the discipline, the true intent is obvious. The focus rests entirely on intense neuromuscular control, a sharp contrast to modern misinterpretations of the method as a high-sweat fat loss tool. The clinical efficacy of the modality is rooted in physiological efficiency rather than maximal metabolic exertion. A consistent practice yields an optimized physical state, preserved lean body mass, reorganized fascial tension, thickened deep stabilizers, and reduced autonomic stress. These results suggest that while caloric balance remains the foundation of weight loss, it cannot account for the way a body is physically reshaped. True transformation is achieved by changing how the body structurally holds itself and metabolically rests.